with the title Semantic Information Retrieval. I am Sarika Jain from NIT Kurukshetra, and my talk today advocates the semantic intelligence for information retrieval that will be paving way to intelligent applications. The agenda of the session will be yes, information retrieval. That is the major thing for this FDP. Then I will go through explaining what is semantic intelligence, the enabling technologies for it, knowledge graph as the semantic data model, semantic web vision, linked open data cloud, and I will close it with how these semantics help in information retrieval, that is the semantic information retrieval, with a list of selected bibliography. I start with information retrieval, as most of the people spend their time on internet. Among them, more than 20% of people spend their time on searching. More than 90% of the activities on the internet is search. So search is the most important for internet users. Search is in fact one of the applications of information retrieval. Others being recommendations, question answering, information filtering, and so on. As you can see, here we have looked for what is the date of birth for Michael Jackson, and we are getting the answer. The Google search engine is giving direct answer to us instead of delivering different pages, and we go through the pages. So this is today's Google search, and we will see how Google is able to give direct answer to our queries. If we define information retrieval, there may be, because I have not listened to other speakers of this FDP, so there may be certain overlap. As defined by Salton in 1968, information retrieval is a field that is concerned with the structure, analysis, organization, storage, searching, and also retrieval of information. As you can see in the diagram, the document collection is there. You retrieve it, the user query it, and then the answer list is submitted to the user. It is a bit different from information filtering that people sometimes confuse. Information retrieval is changing the queries on stable document collection. As we have just seen, the document collection is stable and the query may keep on changing with different answers for every query. While in information filtering, what it does is the documents are many, the query is the same. The query means the user profile. So there is an incoming document flow with stable interest, with the stable user profile, with the stable queries. Say I am querying, I want to filter certain documents. Some will be kept and some will be ignored. That is the major concept of information filtering as different from information retrieval. Here is a top shot architecture of information retrieval. As people go through it, a very simple architecture, but I like to go through it for a minute so that I could explain the other slides. We start from document gathering, select the documents, index the documents, and then we are ready with the indexes and the document databases. Then in parallel, the user will come to search. User has his information needs, they will be represented, and a query is generated. For every new query, there is a match with the index documents that were indexed already. The query is matched with those documents and some documents are retrieved. So we have document and query management, that is matching is there. The documents which are returned are maybe ranked and then answers delivered to the user. So this is what is information retrieval as we know it till date. There are certain challenges for information retrieval. Synonymy, polysemy, the major ones. Synonymy everybody knows, whether we call it a car or an automobile, whether we call it a jaguar, that is polysemy will come. Table has two different meanings or many different meanings can be there for a table. Then we have ambiguous and incomplete queries. The query itself can be ambiguous and the system, the information retrieval system, has to understand the exact intent of the query. The query may be incomplete in itself. Content representation is a challenge because it may be inadequate at times. It may be incomplete at times. Missing semantics is one of the challenges which we will be tackling today, and we'll see how the missing semantics poses a problem to information retrieval and how do we overcome from it. Relevance is one of the challenges because user is the ultimate judge for information retrieval tasks. There is a question on his judgment. What a user judges may be different from what other judges. That is relevancy. Maybe some answer is relevant to him and the other is not. What is relevant is very imprecise, and it is also context and user dependent. Information retrieval on the web is in itself a challenge because the document collection is unstable. We have different spiders and crawlers for it. The documents may be invalid, they may be duplicate on the web. The document collection is very huge on the web. The big data problem, the document collection is multilingual. I hope all of us understand what is multilingual document collection. The document collection is in itself multimodal also. We have different types of formats. We have different, for example, images are there, videos are there, textual data is there. So we have to cater with these challenges, and today we'll go for the semantics challenge majorly, which will in itself may cover most of the challenges as we will just see today. Let us start with artificial intelligence, and we have to look how AI can help in information retrieval. So let us see what AI can do. To start with, I have an example with games, how AI is playing a role in games. In May 1997, it was IBM Deep Blue. It conquered the world chess champion Garry Kasparov. May 2017, Google AlphaGo has won over world #1 Go player, the Chinese KG. In chatbots, February 2011, IBM Watson, you might have heard of, it was victorious at Jeopardy. The Watson supports in today's date 11 languages as of March 2020. IBM Watson is a chatbot. In semantic search, I have an example of Google itself, that is the most popular semantic search engine. Otherwise, you might have heard of Google and many more. Google decided to call its semantic search as knowledge graph. You can see on the right hand side inside the image. If you search for Tom Cruise, yes, the different 10 documents on first page, many documents come in. The Wikipedia document is the first document that has come when I searched for Tom Cruise. But on the right side, if you can see, there is an info box. This info box contains all the necessary information which a user might be asking regarding Tom Cruise. So this is semantic search using knowledge graphs by Google. There is example of digital assistant. So AI is doing it. We have Badu's personal assistant Doer accepting orders at KFC restaurants in China. Apple's Siri, it answers questions and make recommendations. You might have heard of all of these. So all of these are AI applications, but we have to see how semantic intelligence comes in. So let us have a look on various problems and challenges of different intelligent applications. As the world is loosely coupled, the IT world of today comprises of many OS, many operating systems, many high-level languages, many types of networks, and so on. So we have a problem of data silos. All data are different formats, all are separate. They are multi-source data, data warehouses has data, data lakes has data, files, analytic platforms, they are multi-source. Then you have heterogeneous information assets. The information can be in the form of files, tables, code, dashboards, and so on. So resulting in the data silos, which are becoming demos in today's date. Another important problem is interoperability. What if required to combine results from the heterogeneous sources, and that to multiple heterogeneous sources? Interoperability is the, you can say, exchange of information. If it is achieved only when a common representation is used between different systems, you say that you have achieved interoperability. Big data and the information overload is another important challenge, because due to many technological advances, many technological trends, huge data, as you all know, is generated daily. The three V's, the so-called three V's, volume, variety, velocity, pose numerous challenges, because so huge data is there. The IoT data, social data, data on the web, cyber data, event information, and so on. There is a lot of data available. We call it the big data problem. We have poorly solved information needs. An example is the search engine. Search engines give documents, but they do not give data. I repeat, as you can see, Google search engine, you have a list of documents. Then you have to go through the documents to find the necessary information. The example I have just shown of Michael Jackson date of birth, that is semantic search, because Google has come into semantic search in today's date, and now it is giving data also as compared to documents. So we need to give answer to a specific question. We need to support the precise or the structured queries also. Redundancy is another challenge for intelligent applications. What is redundancy? You can have a look here. Otherwise, an example, same entity represented in multiple forms. For example, Barack Obama, you can also say Barack H. Obama, President Obama, Senator Obama. The different databases may talk about the same entity using different URIs, as you can see here. It is Tim Berners-Lee at one place and Q80 at another place. So redundancy is a problem. Another major problem is unstructured documents, mostly unstructured and at times semi-structured data also. There are some more problems which I have listed here. Scalability, everybody is aware of. It refers to the property of a system to handle or to cope with a growing amount of work by adding different types of resources to the system. Another problem is vastness. Then vagueness. Yes, imprecise concepts are there, young, tall. So fuzzy logic helps in vagueness. Uncertainty is a problem. The precise concept we have, though we can have precise concepts, if vagueness we remove, then we can have precise concepts. But those precise concepts may have uncertain values at any point of time. For example, a patient might present a set of symptoms to you, and these symptoms may correspond to different set of diagnoses also. And every diagnosis will have a different probability. So probabilistic reasoning come into picture. We have logical contradictions in place, that is the inconsistency problem. Then deceit, yes, you have misleading information, and cryptographic techniques suit best for the deceit problem of intelligent applications. Altogether, how do we cope with all these problems and challenges? Let us have a look to it, and semantic intelligence comes as a solution to it. You might just have a look on this DIKW pyramid, the very famous pyramid from data to wisdom. We need to reach from data to wisdom. What is data? It refers to raw facts. It refers to the symbols, the numbers. The numbers can be unstructured or structured, means we know nothing about it. We just have the raw facts. When data put to certain context, it becomes information. Context and value adds meaning to data. For example, if I speak 2006 2020, then in the context of date we can recognize it. We can recognize its value as 20th June 2020. So it gets a meaning and it becomes information when it is put to certain context. Then comes knowledge. Experience added to information becomes knowledge. How is the information that is derived from the collected data becomes relevant to our goals? The pieces of information connect to add more meaning and value, and it can then be applied to achieve our goal. We say that it has become knowledge. When some information becomes useful, we say that it has become knowledge. So you need to define the relationships for information. When you have the information, you know the who, what, when, and where. And when you have experience, when you come to knowledge, you know the how also. Now you know the how of everything. You know how the things, how the task will be conducted. Now you are understanding the patterns. And the explicit information plays a very important role here, because knowledge comprises of both types of information, the explicit and in fact implicit information also, and you have the clear awareness. What is understanding? We are reaching the pyramid till wisdom. Shared understanding and intelligence comes into picture after you have attained the required knowledge. Understanding is some form of stored knowledge. For example, the table of 2. When understanding is added to it, now the student is able to answer difficult questions like the multiplication 1230 into 45. The student is able to answer. So the stored knowledge, that is the table of two. But if you understand that table of two, then you are able to answer the very difficult questions also. Just having knowledge is just memorizing the table of two. But understanding is learning the concepts. Learning means growing the concepts. If you understand the table of two, you are able to answer all the multiplication problems which involves the table of two. So synthesizing the new knowledge from old knowledge is what is important. Now you understand the principles. You act using knowledge, so you know the best, and also you know why you are doing it. So you achieve wisdom, the judgment and the action. Now you achieve wisdom. You can see here on the right hand side, when you go down to data, then meaning, applicability, value, equivalent to human, all decreases. And when you go up, then you get a value which is equivalent to human being. Going down is what happened, that is looking back into the past. Going up means what will happen in the future. So you have to achieve wisdom. You have to look into the future. What is knowledge management? Now there is a big question, what is knowledge management? Because from data we have established that we have to attain knowledge and then wisdom. Wisdom is something that is only with human, and till date AI is not able to achieve wisdom into machines. But yes, in the DIKW pyramid, the human being is able to make the machine reach till knowledge. So we do not need to manage the data or the information, we need to manage the knowledge. There comes knowledge management as the process of creating, sharing, using and managing the knowledge and also the information of an organization. It refers to a multidisciplinary approach to achieve the objectives by making best of our knowledge. This is what Wikipedia defines knowledge management. Let us have a look how we do all this. So what we understand by now is semantic intelligence is required for semantic information retrieval, and for semantic intelligence we need to reach to knowledge management. May I ask the participants to hold on, please. I have to attach charger to my system.
Yes, ma'am, please.
Yeah, just a second.
Yeah. So okay, so let me request participants if they are having any doubt, any basic doubt. I mean, how basically we can utilize this semantics property of semantic or semantic intelligence of the data for any kind of information search or information system. So they may raise their doubts, their questions, and particularly how basically AI is changing the face of semantic intelligence or semantics of a data for achieving any task, right? So because from here we are now, I think, towards AI based semantics or maybe intelligent semantics. So I request participants if they are having any query or questions, they might ask, right? Yes, ma'am, please continue.
So I'm back to it. So if there are any queries, we can handle because we already had a break in between.
Yes.
Otherwise, I can continue. I cannot
Yes.
see the chat box. Dr. Vikram, if you could speak if there is any.
No, queries are not posted yet because
Okay, fine.
because session is just now building up interest.
I understand. I understand. So I'll continue. We require semantic intelligence for semantic information retrieval. And for understanding semantic intelligence, we have to climb up the DIKW pyramid. We do not need to stick to data. Do not need to stick to databases. We do not need to stick to data management and knowledge management, the DBMS, the so-called RDBMS. So we need to do the knowledge management now. For doing knowledge management, let us have a clear picture of the different two paradigms of AI research, the symbolic AI and the sub-symbolic AI. So symbolic AI we start with. You remember your traditional AI books, the Rich and Knight, Russell Norvig. We study about expert systems. We call it good old-fashioned AI in today's date. Not in today's date, I should say since 1980. All of that is a gone thing, but we still teach AI from Rich and Knight also, and from Russell Norvig. So there were rules engines, expert systems, that is the traditional AI. They were the first attempts to AI from 1950s till 1980s. You remember all the tools and techniques found in the standard AI textbooks. The propositional logic, if you remember, first order predicate calculus, list, prologue, if then statements, is man X, branch and bound problems, heuristic search. There is no algorithmic training involved, but we have dynamic, verifiable, and explainable model. The expert systems are explainable in themselves because there are rules. But there are certain problems with the symbolic AI. Because of that only, from 1980s, we have switched to machine learning. What are the problems with symbolic AI? It is costly and time consuming because rules are created through human intervention. That is why it is costly and time consuming. Another problem is monotonicity. That is difficulty of belief revision is there. Additional rules are not able to undo the old knowledge. Expert systems are very monotonic. There is difficulty of belief revision. Then another is symbol grounding problem is also a major problem. How do the words or symbols get their meaning? So the solution came in neural network, because neural network is very well bound to the vector representation. So the symbols may not link to any other non-symbolic representation when we work with the symbolic AI. So came sub-symbolic AI from 1980 onwards. This sub-symbolic approach to AI manages to approach artificial intelligence without specific representations of knowledge. That is, without being explicitly programmed, without writing the rules, the machine is able to execute a task. A machine is learning automatically, machine is adjusting to the actions automatically. It is connectionist AI, we call it, statistical AI, and it is the current state of AI. Without being explicitly programmed, the machines are able to execute a task. The machines are learning automatically, yes. The AI research has become more and more scientific. The results we obtain today, they are measurable and reproducible. We have the concepts of evaluation, precision, recall, F measure, we calculate now, since we are doing statistical AI from 1980 onwards. Otherwise, in expert systems, there were no such calculations and it was very less scientific. So what is the major beauty of sub-symbolic AI? An example is machine learning, deep learning. Now, what is the beauty of it? We have a classic example of translating a note from language A to language B. How do we do if we have only symbolic AI, if we have only expert system, the Rich and Knight book? Then what we do is we have a dictionary which has translations from language A to language B. We will get a note in language A. We will look for all the words inside the dictionary one by one and translate it from the dictionary into language B. Yes, seems easy, but it's a bit difficult because if the text given is long enough, then you have to scroll through the dictionary one by one many times. But how beautiful it will be if the machine is asked to learn how to translate language A to B. If the machine understands both the languages A and B, then how easy it is. So this is machine learning. The machine is able to learn both the languages, and if it is asked to translate, it is able to translate it easily. So this is the beauty of sub-symbolic AI, but there are again certain problems, and not certain, I should say. I have come here with a list of so many problems with the sub-symbolic approaches, because that is the major theme of semantic intelligence. So let us go through the problems of the sub-symbolic AI. Humans reason through high-order semantic abstractions, while machines reason through blind adherence to statistics directly. This is the most critical distinction. So I come here with the first problem, that is the cold start problem. As you all know, for machine learning algorithms, you need a lot of data. You need data sets. Yes, Kaggle is there, but then also there are certain data sets for new problems, which are for example, for some emergency that has just happened, a new emergency. You do not have data. So how will the machine learn? So this sub-symbolic AI is data hungry. Another problem is black box AI, that is the lack of model interpretability. Sub-symbolic AI automatically extracts patterns and rules from large data sets, and it automates the classification task. That is good. But why the things are classified in one way or another cannot be explained, because machine learning cannot reflect on why which rule is extracted. It is a very intrinsic nature of machine learning algorithms. But humans are such creature that if they are not explained of some decision, then there is risk of it making a wrong decision, because final decision is to be made by the human. So they need to be explained of what is being done. And machine learning AI, the sub-symbolic AI, is the black box AI. They do not explain anything. So today is the concept of explainable AI is coming into picture. Again, the language translation example, machine learning task, they will learn all the languages, they will translate A to B, but they will not explain how they have translated and which rules they have adopted for doing it. Sub-symbolic approaches are self-contained. They are not well integrated with the prior knowledge, and it makes them brittle and easy to fool. They search for correlations in data, I should say, rather than meaning. They search for correlations and they do not search for meaning. Machines blindly search for the strongest signals in a pile of data. They lack a cushion of background knowledge. They lack the life experiences. The deep learning algorithms are not able to distinguish between the meaningful and the spurious indicators. But what they do is they blindly encode the world according to stats. They do not look for semantics. I should add, the background knowledge and experiences provide the necessary context to reason about the patterns. Through this only you are able to identify those patterns which are most likely to represent the actionable knowledge. So background knowledge becomes that important. We have an example of, for example, you say outdoor dogs and indoor cats. There is a problem with sub-symbolic AI. You say overfitting problem is there and underfitting problem comes. For example, you say when it is outdoor, then it is a dog. When it is indoor, it is a cat. For cat also, when it is outdoor, then it should be a tiger. So how does a machine differentiate between a dog, a cat, a tiger? That is always a problem. If you take a photograph of a main battle tank, when it is seen in the desert of land, then most humans will label it as a tank. Yet if the camera is zoomed out to show that desert of sand happens to be a backyard sandbox with a young child's hand holding the tank, then human can say that yes, it is a toy tank, but the machine will again say it a battle tank. So this is a problem, that the patterns learned by machines are extremely brittle. They are the observational visual characteristics of input data rather than the abstractions of the world. So that always becomes a problem. Again, the next problem with the sub-symbolic AI, diversity in training data, which is so critical to ensure that a machine sees a wide range of counterexamples that cancel out the patterns which are spurious. So it is not realistic. Input features have to be very carefully selected and normalized. While the training data is so diverse, so there comes problem again of overfitting, underfitting comes. The stability assumption is there. The data-driven algorithms assume that the model of world they're capturing is very stable, but which is not so. We miss the common sense reasoning also in the sub-symbolic AI. You know, Kaggle is providing everything very neatly packaged as compared to sporadic data that is coming from the real world. So common sense is missed. Even deep learning is struggling with the open-ended inference. For example, John promised Mary to leave. John promised to leave Mary, but you're not able to now draw inferences about who is leaving whom or what is likely to happen next. Monotonic reasoning is another problem. Retraining is necessary to adjust the new incoming data. Otherwise, it will become monotonic. New data is always there because their data is always incomplete. But whenever new data will come in, you require to retrain your machine. Exception handling. Exceptions are treated as noise by the classical machine learning algorithms. For instance, if the training set consists of descriptions of different kind of birds, say classified as either a bird can fly or not, then the records concerning penguin or ostrich will definitely be treated as noise by ML algorithms. Now you can see the mission critical applications. Subsymbolic AI works well as approximations, they work well. But when it comes to answer in mission critical applications, it is very challenging. For example, you can say out of distribution inputs are there. You can see a motor scooter which got confused with a parachute just because it was toppled over. You can see a school bus with confused with a garbage truck by the machine or a punching bag. You can see the third example, the fire truck getting confused with a school bus. So the surroundings of the vehicle play an important role for being inferred by an ML algorithm with a certain level of probability. We have no idea what basic scenario might cause them to suddenly fail, and potentially when it is mission critical application, then you will have fatal consequences. So what I mean to say is, we have symbolic AI. We had symbolic AI from 1970s to 1990s. We called it good old fashioned AI. Then from 1980s, or we many times called 2000s also, it was sub-symbolic AI. CNN, deep learning, statistical learning, advanced text and speech processing, that is learning came. So sub-symbolic AI was good at learning. Symbolic AI was good at reasoning. There was no ability to learn. So from 2020 onwards, the focus is on contextual computing, the explainable AI, XAI. Now you can converse in natural language because the proper translations are available. Learning is there, reasoning is there. Reasoning has come from symbolic AI, learning has come from sub-symbolic AI. It is the contextual adaptation which is able to explain the decisions. So we have to work with contextual computing now onwards. So what I mean to say is, we need to couple the two approaches. This is the hybrid of knowledge engineering, the contextual computing. We have to couple the sub-symbolic and the symbolic approaches. They have to come together. If there is some noisy data, let us have some examples of how they can be clubbed. The first example comes here. If there is some noisy data, it is to be gathered through sensors. You need to gather the data through sensors, and it is to be processed through maybe ANN, the artificial neural network, to infer some discrete information about the environment, and the information has come from the sensors about the noisy data. So this is sub-symbolic approach. Now what you do is you feed this information to a symbolic algorithm to recommend a possible course of action. So you have merged the two. Misclassification, which is caused due to some statistic. This is another example. The misclassification caused due to some statistical bias or noisy sensor readings. What you can do is you can overlay it with a symbolic constraint system to ensure the enforcement of what is logically obvious, what is manly obvious, what human beings think about it. The examples include high-risk applications like managing power stations, dispatching trains, autopilot systems, and space applications, and so on. The implications of misclassification in such systems are much more serious than recommending a wrong movie. And also for the contextual computing, that is the hybrid, there is a top-down and bottom-up contrast. One way of looking at these technologies is that using a knowledge base, as in semantic technologies, is a kind of top-down approach towards intelligence, where you feed in learning and knowledge from the top, where you feed in learning and knowledge from the top. That is a top-down approach. It is this sort of approach of learning that comes in semantic intelligence that makes human beings immensely powerful, and human beings are able to learn from the theories, from the background knowledge that is stored since generations. This is the top-down approach. And this is exactly how human beings or human babies learn how to perform certain tasks. This is top down. They observe it from their parents. By copying their actions, the babies are able to learn different tasks. While on the other hand, the sub-symbolic approach is bottom up. The ML techniques can be said to be bottom up approach towards learning. How? Here one is exposed to masses of unstructured data and you work out different patterns or correlations within the data. This is perhaps exactly the manner in which human babies learn how to walk. How do human babies learn to walk? It is not just by observing their parents, but also over numerous tries they make. 1, 2, 3, they fall down, they get up. So this is how human babies learn to walk. This is the bottom-up approach, the ML approach, till they refine to a particular solution. We need to understand semantics. All our work, our whole life is a matter of semantics. As Frankfurter said, semantics is but misunderstood and mostly unappreciated. Semantics clarifies the sense of a sentence by constructing a relation between the adjoining words. Syntax describes the correct format. Semantics describe the required comprehension and the correct interpretation also. As you can see here, the first one is syntactically wrong. Semantically, we cannot say about it. The second one is, yes, syntactically correct, but semantically wrong. 3 plus 4 cannot be 12. The third one is syntactically correct and semantically also, because 3 plus 4 is 7. So semantics is words are there, the accumulated background knowledge is there, and the words and the background knowledge when put to certain context, we call it semantics. The IT world of today comprises of many operating systems and many heterogeneous things. The interoperability problem is always there, and we call it, there is a semantic gap. In all those heterogeneous things, there is a semantic gap. You can see here that this is the data as is perceived by machine. And this is the apple, that is the human perception. Different users may have different interpretations for the same vocabulary. Closing the semantic gap means to define the intentions of each model type by the description of the modeling methodology to apply. What is the approach? How do we cater to semantic intelligence? From where this semantic will come? How to close the semantic gap? We need to close this semantic gap that we have just understood. Let us look at the approach that is to be taken. For example, let us, for example, if we have a search for Tim Berners-Lee, you know who is Tim Berners-Lee? He has come up with semantic web idea. So a search for Tim Berners-Lee fetches information from different sources and creates a knowledge graph. We can see here two information sources, two knowledge sources, Wikipedia and Wikidata. In Wikipedia, there is some other information for Tim Berners-Lee. In Wikidata, there is some other information of Tim Berners-Lee. Wikidata, we can see the sibling. We can see in Wikidata the sibling of Tim Berners-Lee, the audio, the residence, that is USA, Concord, New Hampshire. In Wikipedia, what you can see is the information about his two children, the information about his two spouses, that is Rosemary Lith and Nancy Carlson. Now, for searching Tim Berners-Lee, both the knowledge sources are being consulted. A knowledge graph is created and the complete information is together at one place. What was the problem? In Wikipedia, there may be a different representation. In Wikidata, there may be a different representation. But you have created a knowledge graph together by retrieving the information from both those sources. Semantically, you are retrieving the information. You are putting them semantically into a knowledge graph. We will come to it in later slides. What is a knowledge graph and how do we create it? So you are creating a knowledge graph of all the information from different sources. And now the answer to Tim Berners-Lee search will answer all these things which are visible in this knowledge graph and not only from one source. So you are able to now build a rich user experience by combining knowledge regarding the input keyword from multiple sources. You use a semantic web knowledge graph. Why? For augmenting ML problems with the background knowledge. That is very important. As I mentioned, the background knowledge as a problem of ML, as a problem of the sub-symbolic approaches. So here I come to define semantic intelligence. AI solves isolated problems based on the isolated data silos. We need to link artificial intelligence with machine learning, knowledge management, and we reach to what we call semantic intelligence. Semantic intelligence refers to filling the semantic gap between the understanding of humans and machines. How it does it? By making a machine look at everything in terms of object-oriented concepts as a human look at it. All the important relationships in the data, who, what, when, where, how, and till why, that is till understanding. All the important relationships in the data from any heterogeneous data source are required to be made explicit. How are they made explicit? As we have just seen, they are made explicit into one knowledge graph. Let us have a look on the various characteristics of semantic intelligence. We have now the semantically rich data, which is the quality data. We have data as compared to documents. We have information as compared to processes. I think there is some background noise, some mouses, some mic is on.
Yeah, it is fixed now.
Okay, I'll continue, not a problem. Semantically rich data is there when we have semantic intelligence. The major characteristic is we have semantically rich data. You will appreciate it. And I think you might have understood it that we are not working on documents now. We are working on data. Now you are able to fuse the symbolic and the sub-symbolic approaches to AI. We have the semantic data model in place, that is the knowledge graphs. Ontologies and knowledge graphs serve as the semantic data model. Ontologies is the new term that is just now introduced. To speak a few words about it, from philosophical days, ontology is a term which speaks about hierarchy. That is, which speaks about what is a thing. The concept of a thing is explained in a hierarchical manner by an ontology. To be more specific in technical terms, I can say people work with RDBMS. The schema of the tables is the ontology. The data of the tables is the knowledge graph. So we have a proper mapping from RDBMS to the semantic world also. Traditionally, when we were faced with the heterogeneous knowledge in machine learning context, then the data scientists pre-process the data. They used to engineer the feature vectors so that they are used, so that it can be used as input to the algorithms. Now, as ontologies and knowledge graphs are able to better represent the heterogeneous knowledge, they serve as the data model and they are able to bridge the gap between structured and unstructured information. We have data as a service. Linked data acts as data and it acts as a service. We have open linked data, which is used as a training data for the ML algorithms. There is no mystery. There is no black box. We have the explainable AI. We are going towards the self-optimizing machines as a virtuous cycle. ML is feeding the ontologies, and in return, ontologies are able to improve the ML algorithms by providing better feature extraction, by providing better precision. Systems with semantic intelligence work well like self-optimizing machines. Once they are fed into it, they will work like self-optimizing machines. Semantic search supports knowledge search. It is not only the document search. Understanding information is an important characteristic of semantic intelligence. It has climbed up till the information, knowledge, and till wisdom pyramid also to some extent. We are able to understand the information. The computers are able to understand the information like human beings do to enhance their intelligence. There is no ambiguity for polysemous keywords or the synonymity, as I said in the previous slides. Connectivity is one of the characteristics because information is now more connected. The user experience is able to leverage all the available information. Ubiquity is an important characteristic. Capacity of being everywhere is called ubiquity. Multiple distributed applications. The content is also accessible by multiple applications. That is ubiquity. The services can be used everywhere. Next is there is no need for the mega database. That is the data warehouse model is not anymore required. Resource description framework, RDF, facilitates data merging from multiple heterogeneous sources. I have to speak about RDF also for a second. RDF is the data model. That is a common representation format, better than XML. Everybody might be aware of, all the audience, XML here. So RDF does what XML does, but in a better manner. To simplify it, I can explain it. RDF works better than XML, and it does all the things what XML does. So RDF facilitates data merging from multiple heterogeneous sources of data without combining it. It is more important. You do not need to combine all those sources of data. Then also RDF is able to facilitate the data merging. The data sources remain separate. The relational and the semantic technologies work together well. It is an important characteristic. It supports the evolution of schemas over time without requiring all the data consumers to be changed. Here comes the various enabling technologies, that is the semantic technologies, which people need to learn, people need to understand to work for semantic intelligence. We are hereby combining the two types of learning. So the ability to access stored knowledge is the semantic technologies, and the ability to figure out new and unique problems is the machine learning. All the audience here might be aware of the ML technologies, libraries and frameworks, Keras, TensorFlow, PyTorch, the Apache MXNet. Let us talk about the semantic technologies today. So you always find a plethora of workshops and FDPs on machine learning. This FDP, not the FDP, this course, my talk is mainly about the semantic computing. So let us look at the enabling technologies for semantic computing. You can see in the first column from 1988 onwards, Unicode was there, HTTP, HTML, URI. All these make the foundational technologies for the semantics. What is URI? URI is a unique code given to everything. That is because now we are talking in terms of things, that is the object-oriented concepts. We will not talk of documents, we will talk of data. For the serialization, there was XML. Now XHTML, JSON, then there were different formats, RDFA, micro formats, JSON LD. Turtle has come in 2014. As the data model, as the metadata, we have RDF, which is solving all our problems. There was NoSQL revolution from 2008. What is NoSQL? It has come as an easier approach as compared to SQL, because for SQL, for DBMS, people used to satisfy the ACID properties. So to relax the ACID properties, NoSQL revolution came, and many applications have been developed, and today also we are working with NoSQL databases. But now in today's world, NoSQL is also losing its shine. We are working with RDFS now as an ontology, we can say, as an inference. For inferencing, we can say we require a data model, that is semantic. So RDFS comes into picture, which adds semantics to RDF. There is RML, there is OWL, DML plus OWL, SWRL as the semantic web rule language, OWL 1.1. Sparkle is there as the query language. It is also similar to SQL. With SQL, you are able to query a DBMS. With Sparkle, you are able to query a knowledge base. Because from databases, we have come to knowledge bases today. You need to query a knowledge base, you use Sparkle. Look here, the cost of operation and the semantic flexibility is as we go down, the cost of operation increase, and as you go
Yes, I think we lost audio. This is screen is visible. Dr. Sharika, we lost audio. So we need to wait for the response. Dr. Sarika, I mean, we have lost your audio as I think screen, this shared screen is perfectly visible, but we are not able to hear you. Okay, so participants, so I think I need to connect to her so that, yeah, so I think she might be reconnecting. Okay, so let's wait for 2 or 3 minutes. Okay, let me share a particular announcement that I will be sharing through mail also. So tomorrow, maybe after session 2, so basically after 2 o'clock, so after session 2, I will be sharing a link for the test, right? For the quiz which we have announced in the very first day of the FDP, that to qualify to get a certificate, you need to score 60% of the quiz. That is precondition from AICT. So I will be sharing the link for the quiz after the second session, session 2 of tomorrow. Right, because during this session third, we have a different kind of session which is based on life skill based discussion. So it is covered by art, one of the experts, one of the trainer of art of living. So the session 3 will be there, but I will be posting the link for the test, and that test will be active only for 20 minutes, right? So it will be having 20 question, but test link will be active for 25 minutes, something like that. So it will be of completely of MCQ based, and and the questions will be of very basic kind of questions. So, so you do not need to worry about that, how to prepare for that quiz. Uh, right, that's the only thing I can share. So there will be 20 questions. There will be 20 questions in that quiz, and each question will be of nature MCQ. Each question will be of related to the fundamental concepts of information retrieval, right? So I'm not going to have any specific question from any session which we have planned, because we are trying to prepare questions or MCQ based questions by keeping this information retrieval in the theme. That's it. We're not keeping any particular session on the mind while preparing this quiz or test. So there will be only 20 questions. Each question will have 1 marks. There will be no negative marking, and to answer that quiz, you need to take 25 minutes maximum. That's what we can take, right? So after 25 minutes, I will be closing the response sheet, because this quiz will be happening on Google form only. So after 25, so it is like 2 to 5. So it will be closed. So we will be posting the link to you maybe exactly 2 o'clock, just before closing the session 2, and by 2:30 or 2:25 we will be closing the response. So it will be fine, I think, because it is a condition or precondition from the AICT also. So we need to take care of that part, and that we have to go through a test. Actually, that's the way. That's the purpose. That's why we are planning this FDP quiz, right? So that's the only announcement. And after this, let me see whether Dr. Sarika joined or not. So she might be trying. When there might be some technical issue, she will be connecting with us at any moment. Let me draw the message. Okay, so if any participant is having any query related to FDP conduct, or what is the formalities, maybe after the sessions gets over. So if any query is, I mean, if you are having any query, you can post. So there is the one concern raised by our participant that are related to attendance sheets. So yes, attendance sheets are are basically directly downloaded in the form of HTML pages. So those, if it is not opening, you need to download it. That's one thing. So it, in my system, they are perfectly opening in the browser. So if you are facing some problem, I will be able to provide you of these records into a Excel file. That's no issue. So maybe after this today's session gets over, I will be providing a proper a formatted file which can be easily accessed by each and every participants. Right? That's one thing. Okay. Yeah, so that's something. And second query is second instruction which I wanted to share is that uh, once this sessions gets over tomorrow, you need to immediately apply. You need to immediately fill the feedback form, right? Feedback form which is available in your profiles, Atal profile, Atal web page which you have created to apply for this FDP. So on that profile, this feedback option is visible, right? So once I finish with uploading marks and attendance of your different days, you should be uh, filling or uploading your feedback for the FDP. So these are the three things. So once you upload this particular FDP feedback, there is nothing required from your side. Your certificate will be generated, and if you are facing an issue, you can immediately prompt to me that there is this issue, right? So my email ID has been already shared because I have shared multiple mails with you. So email ID is already shared with you. It is with you. So I request each and every participant to kindly email it. Right? Do not raise your issue through mail or through. You can drop a simple message on WhatsApp group. That's one way, or you can simply drop a mail that we are not able to generate FDP certificate, and if you're facing an issue while uploading feedback, then also you can approach, right? So these are something because tomorrow it will be the last day, and we will be. It is as a participant, it is a tendency that we used to be on some kind of hurry. So there might be a possibility of losing these instructions. Uh, so just give me 1 minute time so that I can call.
Vikram sir, you have muted yourself.
Yeah. Okay, so Dr. Sarika is just joining. It'll take hardly a few seconds, right? So I hope things are settled and clear. So let's hope for the best for the tomorrow session also, because the theme for the tomorrow's session, both session 1 and session 2, is this social intelligence, right? How different applications of information search and information retrieval are using this social intelligence, right? So when we say, we are gathering the feedbacks of multiple users to improve application to support this information search, then we can claim that we are using social intelligence, right? Like in case of Google search system is utilizing the different queries posed by a certain region to suggest the query formulation and query suggestion during the information search of a user, right? So whenever we go for Google, it used to give a lot of suggestions, so a lot of recommendations, and these recommendations are naturally gathered or exploited or extracted by observing the different queries from the different users of a particular region, particular area, particular country, something like that, right? So these is a very simplistic, a very naive example of the societal, this social intelligence. Okay, so okay, now we have Dr. Sarika with us. So, no, ma'am, please continue. So we will
I got
confirm that.
disconnected. I didn't come to
Yeah.
know.
Yes.
Uh,
So
so you'll have to tell me where was I when I
yeah, yeah.
disconnected.
So I request participant to be very precisely say where we were discussing. So can anyone tell me? So it is kind of quiz also. So ma'am, please start. Yeah. So I think yes. So any participant can confirm that whether we are discussing this particular slide or not. Knowledge graph as a semantic.
So we were talking about the timeline of how semantic technologies like OWL and all have progressed till 2014. The table which had that. Yes.
Yes, yes, exactly this slide.
Okay, okay.
So
Thank
it
you
was
so much.
this slide which has been freezed actually. Yes.
Okay,
Please
okay,
continue,
okay.
ma'am, without losing any time.
Yeah.
Yes.
Thank you, sir. So I'm back now because the break is already there. Do we have any queries?
So we have one query related to this page. So is page linking process involves semantic retrievals? That's the one query which we have got.
I didn't understand.
Yeah.
Please repeat.
Is page linking process involves semantic retrieval? So if question is not clear, we can ask participant to raise the
Yeah,
question.
yeah, yeah. The participant can come in. Okay, what we do is I can see the time is 4:10. I
Yes.
have 20 more minutes now.
Yes, yes, ma'am. Yes.
Okay,
Sure.
okay. So what we'll do is now let us complete the presentation, and I will leave a few minutes at the end for discussing the queries.
That's the best way, I think.
Okay,
Okay, ma'am,
okay, fine,
please
fine.
continue.
Thank you so much. So we were discussing the enabling technologies for the semantic intelligence. We call them semantic technologies. So we went through this complete table, and what we discussed is as we go up towards the ontologies, we have better effectiveness, better efficiency, we have the better reasoning capability. So we have to work with the knowledge organization systems. Okay, this slide was missed. Okay, fine. I will do it in short now. We started from controlled vocabularies when people came to know about the knowledge organization systems. The best example is Dublin Core. Controlled vocabularies have only a domain specific list of concepts. There is just a list of concepts. There is no hierarchy. There is no relationship between the concept, just like a dictionary. Then came taxonomies, where there is strict hierarchical categorization. The computer file system is a good example. We have thesaurus, where in addition to the taxonomical relationships, you have other relations also. The best example is WordNet. Then you have Foxonomies, the collaborative tagging. Delicious, Flickr are examples. This is free form tagging, not specific relationships are there, may not be hierarchical relations. Different conceptual models come into picture. The entity relationship diagram, EER, UML is there. For DVMS, it is EER. And unified modeling language, we have a data model, UML. Then comes ontology as the highest understandable model because it provides knowledge representation and reasoning. It provides machine readable as well as interpretable semantics, classes, instances, relationships, properties, and so on. FOAF is a famous ontology, PISA ontology. FOF is friend of a friend. Knowledge organization systems therefore capture the most complex thoughts about the concepts in the form of relations, properties, constraints, and rules. I have to skip this. The knowledge organization systems facilitates effective query answering and reasoning with explanation from structured through semi-structured to unstructured problems also. It suits content management and classification by providing a standardized and common vocabulary for structuring the knowledge of a specific domain. It supports at all levels of an enterprise and the government system, say it be operational, tactical, or the strategic level. It eases the reusability as it aids the introduction of new requirements and functions to any system without major rewriting of the code. That is important. That is why we say that the reusability is itself eased. It provides data integration and inference. So we have come to knowledge organizing. From data organizing, we have come from DBMS to knowledge management. We do not need to manage the data, we need to manage the knowledge for better understanding of everything. There are various ontology variants. Now you are aware of what is an ontology. Many different forms of conceptual models are interpreted as ontologies, varying in different dimensions. There are varying forms of ontology based on appearance, scope, degree of formality. They are discussed here. If I talk of appearance, you might have heard of, in artificial intelligence, you might have heard of semantic networks, frames, then scripts are there. So these are the different forms of ontology only. They are different in the form of appearance. Based on language which is used to represent the ontology, we have DML plus OIL, RDFS, OWL, and many others. Some may be unknown also. Based on the scope, we have the top level ontologies, that is we call upper ontologies, examples being SUMO, CYC, FOAF. We have different domain ontologies for different domains. Disease ontology is an example. Then we have application ontologies, and we can also have the lexical or the terminological ontologies. WordNet is one such terminological ontology. Based on the degree of formality, how formal it is being, that is the level of axiomatization. That is the number of rules which are defined, the different types of axioms and constraints which are added into the ontology. We have ontology variant. As I have just discussed in the last slide, we have thesauri. Then we have simple concept schemes. For example, FOAF, we have taxonomies, that is the hierarchy. We have certain other relationships other than the ISA, that is the subclass superclass relationship. Then we call them the conceptual data models, UML and EER. We have rules and fact bases, and the highest level is the general logical theories we have. So let us go through 2 slides or 1 slide for the general confusions and clarifications the semantic people have, which works in semantics. What is ontology and what is a knowledge base? There are 2 new terms introduced, that is the T box and A box. For the DBMS people call schema, we call it a T box, that is the terminological schema. The terminological knowledge is the T box, and the instances, the facts, the rows of the table is the A box. I think it is very clear. What is T box? That is the schema. What is the data? That is the A box. And both of them together make up the knowledge base. This T box is the ontology. Usually people call ontology as the schema. Some people call the complete knowledge base as the ontology. So it is up to your definition. You could define it anyways. For my sake, I consider schema as the ontology, that is the T box as the ontology, and A box I will call the knowledge graph, that is the data I will call the knowledge graph, the instances, and the knowledge graph and ontology together make up the knowledge base. There is difference between the ontologies and various conceptual models also in terms of usage and purpose. When I say then there the conceptual models are means to construct a technical system anew. That is the usage and perspective. If I say they are not consulted and modified when the DBMS is in use, while in contrast an ontology is consulted always at runtime also. When we say the ability to access the implicit knowledge, reasoning can be performed over the ontologies, so that the obtained answers include implicit as well as the explicit knowledge, while a reasoning cannot be performed over the ER diagrams. Expressivity of the knowledge representation, we have more expressive modeling constructs like negation, like class inclusion. Therefore, typically not found, they are typically not found outside the ontology engineering. So we have knowledge graphs as the semantic data model. A knowledge graph is an intelligent model that presents real-world entities and their relationships to one another in a graphical form, in a graphical structure. A query like Taj Mahal has much richer meaning than just the 2 words Taj and Mahal. When they come together, they make a Taj Mahal. A knowledge graph helps us discover new information quickly and easily. Private knowledge graph examples, you have just seen Google knowledge graph. Yahoo knowledge graph is there, the Facebook entities graph is there, Microsoft Satori is there. We have public knowledge graphs, the universal knowledge graphs, DBpedia, Wikidata, Yago, Nel, OpenCyc, Freebase, all of them are the most popular public knowledge graphs available. Domain specific knowledge graphs specific to certain domains. In life sciences, we can see the maximum work being done. Then there is research space, the British Museum, pharmaceutical industry, telecommunications. Let us see how we work with knowledge graphs. How knowledge graphs enable intelligent applications. You can see at the top the data sources. From these data sources, you transform the data, integrate, NLP is done, and you get a knowledge graph. You apply various algorithms over it, entity recognition, ML, text understanding, and so on, so that you are able to come up with various intelligent applications like semantic search and question answering. Let us have a look. Let us have a quick glimpse on the various application scenarios of knowledge graphs. The first one being Google Knowledge Graph, semantic search. So semantics are there in the search. We do not go through only the documents. There is info box also on the right hand side. There is for discovering the related entities. Google now works semantically, the semantic search. When you say Michael Jackson, then all his music albums, the related music albums also come together. Factual answers are there. You ask for certain query and a factual answer is there in front of you. You do not need to search for it inside the documents in today's date. The LinkedIn economic graph is an example. LinkedIn is also a knowledge graph. We call it the economic knowledge graph. Knowledge graph is serving as a semantic data model. Most intuitively speaking, the structured data meets text. Traditionally, in a machine learning context, data scientists pre-process the data and engineer the feature vectors so they can be used as input. These all transformations can result in loss of information and introduce bias. Knowledge graphs came as a solution. A knowledge graph is a very large, let me define it. A knowledge graph is a very large semantic network that represents knowledge without a strict schema by integrating information from variegated information sources which are heterogeneous in nature. I have brought together the benefits of using knowledge graphs. It allows for true end-to-end learning. It simplifies the integration of heterogeneous data sources and data harmonization. It provides a natural way to seamlessly integrate different forms of background knowledge. Here is the semantic web vision, from where as a motivation semantic technologies came in. Previously we had the read-only web, web 1.0, you are aware of the web. It connects information. For example, the shopping carts and the static web is there. We call it the read-only web. Then the social connectivity increased. It is web 2.0, the social web. It connects people. We call it the read, write, publish web. Example, Twitter, YouTube, and Facebook came in. Then came semantic web. The web 3.0, we call it read, write, execute web. Examples being DBpedia, e-commerce, semantic search. Again, the social connectivity is decreased. Then the fourth quadrant came, which has the maximum information connectivity, the maximum semantics, and the maximum social connectivity, the social semantic web. Web 5.0, 4.0, X.0, the Facebook's open graph. Here is the knowledge graphs are there. Because now we are connecting the intelligence. Previously it was connecting information, then connecting people, connecting knowledge. Now we are connecting the intelligence. Now how to achieve it? Semantic web vision, the web of machine readable data. How to achieve this vision? We need to move from web of document model to web of data model. Web of documents, it was by humans for humans. Wikipedia, humans were writing and humans were consuming. While web of data model, we want machines to do everything, and it is being done for machines also, not only for humans. Humans are able to read and understand, but machines should also be able to read and understand. you have to be entity centric. You have to publish machine processable data and metadata using languages that can be understood by machines. Then you will be able to achieve the semantic web mission. You need to build machines, that is the AI agents, to process this data. Data becoming self-describing. Data interoperability at web scale has come. Openness has come. What is web of data now then? It is linked data plus vocabularies plus the embedded metadata in any format, RDFA, micro formats, etc. Let us have a brief look on linked open data cloud also, because this LOD will serve as the data set for the ML algorithms. I repeat, from not from the Kaggle data set, we will be picking data from the LOD cloud, because all the ontologies and knowledge graphs are available on LOD cloud and open for use. So ontologies have to be picked from LOD cloud. What is LOD rational? From 1998, the idea of linked data was given by Sir Tim Berners-Lee. Knowledge graphs are based on linked data principles. The linked open data cloud depicts publicly available linked data sets. It has come up with 4 principles. Use URI for naming the things. Use HTTP URIs to look up for those names. To provide useful information on lookup. When someone looks up a URI, then it provides useful information, and that too in machine readable RDF format. Include links, that is RDF links to other URIs to allow discovery of still new things. So this is the today's picture of LOD cloud. It has grown such big. An LOD example is DBpedia. This is, you can see DBpedia inside the LOD cloud. This is, I have zoomed it. This is DBpedia. The Google Knowledge Graph is a LOD example. It is, what is Google Knowledge Graph? It is an ontology about everything. Identifies entities in queries and presents data about those entities as results. You search for Delhi and this is what you get. And on the right hand side, you can see an info box about Delhi. So it is satisfying the user's diverse information needs in a single answer. An example is linked data on BBC. The US government's open data is another example. So government is also utilizing the LOD. The Springer SciGraph, Springer, all the documents, all the research papers are saved in the form of SciGraph, a linked open data platform for the scholarly domain used by Springer Nature. For e-commerce, Best Buy is using with good relations on the good relations ontology is used as the background knowledge by Best Buy for the e-commerce purposes. Let us have a look on the trends of semantic intelligence in the next 5 years. Hybrid knowledge engineering, I have already explained. AI applications in healthcare, they will utilize ontologies. To make NLP applications smarter, intelligent question answering, from simple question answering to actual conversation, that is the chatbots. Apple Siri is one of them. Fluently processing domain-specific natural language, AI digital personas, and of course, many more. I will take 3 to 4 more minutes. This is what I've brought in front of you, the semantic information retrieval architecture as compared to the previous architecture that I have come in the beginning of the presentation. So you can see the 2 aspects here, the above and the below. What you do initially is you collect all the documents, you do the semantic annotation of all the documents. Means you annotate them with a background knowledge basis. Any knowledge base you could pick. So you annotate all the documents using the background knowledge, and the annotated documents are put at one place. Then when user comes, the end user sends his query. That query again is represented in the same form, that is RDF. We call it query entity recognition. Then expanded query is one of the major research problems, and the query is converted into a semantic query. Then matching comes, the semantic evaluation. This query is matched with the annotated documents, and you get certain relevant documents which are indexed and ranked to get the relevant result to the user. So this is the complete scenario of semantic information retrieval, and every block in this diagram is a research problem in itself you could pick. As a different example from this knowledge technology website, I have picked it. You can see the same thing. The documents are there. The background knowledge ontology is sitting at one place. You extract the documents. You populate the A box using the red arrow you can see. You annotate the extracted documents using the background knowledge. Annotation is performed. Now the user is coming from the left hand side. He is querying. The query processing is done. And finally, this index is taking the annotation and the query and the background knowledge to build an index to select the relevant documents which are ranked and given back to the user. As an example, there is semantic digital library as an example. What this is doing is it is involving three different ontologies. You can see here in the center ACM topic hierarchies. At the bottom you can see the geo ontology. At the right hand side, without the red block, it is complete the Dublin core metadata. They have taken a portion of domain ontology focusing on the academic thesis. So the semantic digital library has been made. This is the architecture of that digital library that the authors have proposed, and using these three different ontologies as the background knowledge to provide semantic intelligence. Here I come to an end. This is the bibliography. You could look at the video later so that you could go through the bibliography also. Very thank you. Any questions?